When you read this question, I feel like it seems like one of the scariest grade 12 questions that you are going to encounter. But in fact, I think you're going to turn out to really like these ones because they're really predictable and they're like worth 4 marks on a test. And predictable questions worth a lot of marks are things that students start to like, right? It's the unpredictable ones that you're like, I don't know what to do, that stress you out. These ones are very predictable, and one of the things that I do to make them even more predictable, I give them a name. I call these double triangle questions. And if you start to recognize them, oh, it's a double triangle question, what's nice about the name that I give them is it tells you what to do as well. We're going to need to draw 2 triangles to solve this. So when I read this question, given angle alpha in standard position with its terminal arm in quadrant 3 and cos of alpha equals -3/5. We've had questions start like this before. And you have enough information there to draw the angle in its correct quadrant and use its reference angle and draw a triangle. But we're not only given that for alpha, we're also given that for beta. So what we're going to do is first I'm going to take the information from alpha. I know it's in quadrant 3. I can draw it back to my nearest x-axis, and this would be my alpha reference angle. And I know that cos, which is adjacent over hypotenuse, is -3/5, so I can label this side would be 3, this side would be 5. When I label triangles, I just use positive values because that length is 3. Some people put -3 there because they're going backwards. It's not wrong. I just like labeling triangles with lengths, and then I make sure that I use my cast rule later to be able to tell, like, sine in this quadrant is going to be negative, and tangent in that quadrant would be positive. And once you've drawn this triangle, you can do a squared plus b squared equals c squared. Probably recognize this as your 3, 4, 5 triangle. And we've got our alpha triangle. We already knew that cos of alpha was -3/5, but now that we've drawn the triangle, we also know that sine of alpha is -4/5. Next, we can draw a beta triangle. I'm going to change colors here. I'll draw beta in green. We are told that beta is in quadrant 2, so I can draw an angle in quadrant 2. Now this question, label my reference angle for beta. This question was really easy because they told you explicitly which quadrant it's in. Sometimes they're a little bit more problem solving to find the quadrant. Like, if you knew that sine of beta was 1/3, from your cast rule, does it make sense it's 1 or 2? Then they might give you another piece of information like, oh, and by the way, tan of beta is negative. So you would have to use your cast rule to say the only place that sine of beta is positive and tan of beta is negative would be in quadrant 2. Now we know sine is opposite over hypotenuse, so I can label this as 1 and 3. A squared plus b squared equals c squared. That side will be square root of 8. So I knew that sine of beta was 1/3. Now I know that cos of beta, negative because it's in quadrant 2, would be -√8/3. Now we want to find what is sine alpha plus beta equal to. And it says determine the exact value, so this means this is a non-calculator question. We want to find the exact value of sine alpha plus beta. And we have formulas for sine alpha plus beta. We look on our formula sheet, and sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Now from our double triangles, we've already collected information. So one of the reasons that students really like this question is it's not hard to draw the two triangles, and now you just have to plug things in and simplify. However, there is an interesting thing that happens in the next step. The next step is you just have to plug in things, and what I do every year is, because I've found whether I teach it to you and you see the right way of doing it or not, on a quiz or a test, the first time that you do it yourself, you will go with your gut feeling. And I found out that 50% of the class usually gets that gut feeling wrong. And after you find out that you've done it wrong, you usually fix it. So instead of doing it wrong on a quiz or on a test, I always do a survey. I'm going to find out, is this class 50-50? Okay. What do you think? You've got the information here. You just have to plug it in here. I want you to do the next step on your own. And then I'm going to take a survey and find out where we are. I'm going to pause the video here. What's the common mistake? The common mistake is you're used to plugging in values for variables. So the common mistake, and I'm going to do it in red, this is wrong. People plug in like this. Because you're used to plugging in values for variables. And this is wrong because you don't know what alpha is. Anywhere on the left-hand side, do you see it say alpha equals? No. You know, I'll erase this. You don't know what alpha equals, but you do know that all of sine alpha, so I can replace all of the sine alpha, is equal to negative 4/5. This is the correct way. All of cos beta. But it's you're used to plugging things in for values. So if you did that, that's just because that's what you're used to doing. But again, I said, like, usually it's 50% of the class makes the mistake. You guys were higher than that. 76% did it right. That's amazing. Negative 3/5, because you know all of cos alpha and you know all of sine beta is 1/3. Then what do we have here? Well, we're going to have a common denominator of 15 for both of them. And how do you multiply? This is going to be 4√8 minus 3 all over the square root of 15. And you can leave square root of 8, or you can reduce that to 2√2. That's up to you. This would be fine as a final answer. So the idea here is not hard. These are 3 or 4 mark questions. You get a mark for both of your triangles, you get a mark for choosing the right formula, and then you get a mark for simplifying it. Usually it's a 4-mark question, and it is very predictable. So you can circle questions 8 and 13.